All right, so our final example that we're going to do, I know there's some in these notes that we have not completed, but if you look at these and you have questions, I am happy to help. But the last piece here, we are still looking at absolute value inequalities. But before we do so, before we actually jump into a problem, I want to highlight some notes here that you need. So this looks a bit different, but again, it looks very similar to what we have already had. But it says this time that if the absolute value of u is greater than k, then that can be rewritten as u is less than negative k, or u is greater than k. So I'm going to change my screen here just for a minute. Where is my mouse? Give me a minute for that. So I'm going to write that down because that is important for me. The absolute value of u is less than k or greater than k. That is equivalent to u is less than a negative k, or u is greater than k. So it's easy to see now that where before we had an and statement and we didn't really separate that statement into, where you saw the and written out. We left it as a three-part compound inequality. This time with the or statement, we have to break it up. When you have an absolute value greater than some number, it is an or statement, and we have to break it up into two inequalities. We should see two pieces there when you are working this out. So with that being said, let's look at number 16. Number 16, they gave us 5 times the absolute value of 2x minus 3, absolute value, minus 1 is greater than 9. So I'm going to let these guided notes here disappear just for a minute. And we're going to solve this. Now, before I can apply this rule that they gave me, I've got to make sure that my inequality here looks like this. It looks similar to that, but it is not exactly the same. What I notice is that my absolute value here is isolated. It is by itself, right? I do not have a coefficient out front. In other words, there is no number up front, and I don't have plus or minus anything behind that absolute value, just like I do here. So that tells me that I need to move that minus 1, and I need to move that 5. What I need to do is isolate this absolute value so that this inequality is in this form, so that I can apply this rule. Okay? Excuse me. So let's do that. We would begin by adding 1 to both sides, and that leaves us with 5 times the absolute value of 2x minus 3, and that's going to be greater than 10. So now what I notice is I moved that 1, but I've got to still move that 5, because again, this is my goal, my first goal. There's a couple things we have to do here, but this is my first goal. I want that absolute value by itself. So to do that, I need to divide by 5. And that leaves me with the absolute value of 2x minus 3 is greater than 10. So now these are in the same form. Now I can apply this rule. So this tells me that I can leave what I have in my absolute value, u, the same, but we're going to say that u is less than the opposite of k. And in this case, my k is 2. So this is going to be my 2x minus 3 is going to be less than negative 2. Negative 2 is the opposite of positive 2. Then we're going to say or, and then we're going to have u is greater than k. So in other words, it's just going to be what I have here without the absolute value signs. So in this case, this would also be 2x minus 3 is greater than 2. And from there, we're going to solve it just like we did all of the other ones today. I want to isolate my variable, and I'm going to do that by first adding 3 on this side. That will leave me with 2x is less than 1. We want to move that 2 and we're going to do that by dividing by 2, and that leaves me over here with x is less than 1/2. And I want to drop down that or, because I don't want to forget that that is an or statement. And we're going to do the same thing over here on this side. I am going to add 3 to both sides. That will leave me with 2x is greater than 5. Then we will divide both sides by 2. That leaves me with x is greater than 5/2. So this may make some sense. Sometimes I like to graph these so we can kind of see what's going on with our answer. So as a reminder, 5 divided by 2, that is the same thing as 2.5. Just, sometimes it helps us to have a decimal. And then that 1/2, of course, is 0.5, right? So if I were to graph this, what I would maybe start with would be maybe 0, 1, 2, 3, 4, okay? So this has x is less than 1/2. For me, my 1/2 would be right here. And if I'm going less than, it would be that way, okay? And then x is greater than 5/2. And again, this is strictly less than, so I use parentheses, not bracket, because the 1/2 is not included in that solution set, right? We're not actually including the 1/2. And for the same reason here, that 5/2 or 2.5, I'm putting parentheses because that 5/2 is not actually part of the solution, but everything greater than that is. So there is my solution. So this is an or statement. And if you remember, when we go to write these together, we're going to have to, well, let's do this. So we don't do too many things at one time. If we write this in set notation, what would this look like? It's the set of all real numbers x such that x is less than 1/2 or x is greater than 5/2. So that is my set notation. And in interval notation, this would be from -infinity to 1/2 union, because I've broken that, right? So I've got to jump to this other piece over here, union 5/2 to infinity. So yeah, this is everything that you need. This is number 16, and I think you have everything in your toolkit now to work through section 1.7. If there's anything that you guys have questions about, please do not hesitate to reach out. I am happy to help in any way that I can.